Okay, this one is a little tricky because of all the places that you can mess up the algebra. I like to look at these as two separate areas that we're going to add together. So first, I'm going to look at this area. I'm just going to call this area 1. And you can see that it's going from -5 to 0. So you can visually see it goes from -5 to 0. Now, what may be a little bit more difficult to see is that since we're dealing with two functions, we're dealing with g of x and f of x. G of x is here. It's our x-axis. F of x is the nice fuchsia curve. And when I'm looking at this, I hope you can see that the g of x is above every part of the curve below it. So when I say it that way, I'm saying that to find that area, we'll have to take the g of x and subtract the f of x. All right, so let's look at the other area, which is this tiny portion right here. We'll call this area 2. And its interval is from 0, right here, to 1, right here. Now, where some people make the mistake is they will say 3, because that's where the graph stops, but that's not part of the shaded region. So we're looking at those two. Now, when we're looking at that, again, we need to think in terms of what is above which function is above. In this case, as you can see, the fuchsia, the curve, the f, is over the horizontal x-axis. So that tells us that for this part, for area 2, we're looking at f of x minus g of x. So you don't have to write all that. I find it's helpful for me to put things like that right on paper right in front of me. Okay, so let's see how we can find the total area of this. So the area will equal, we're going to look at the integration of area 1, where we're saying g of x is subtracting the f of x dx, and notice that we used from -5 to 0, and it's so easy to leave out a parenthesis or a bracket, so try to go slow. Then we're going to add area 2. So that's going from 0 to 1. And we've established that that is going to be f of x minus g of x. And again, careful that you put in your parentheses and so forth. All right, so let's get in here a little bit further And let's actually plug in our g of x and f of x. So g of x is 0. And then subtracting the f of x means we'll be subtracting 15x minus 2x squared minus x to the third. So again, that's our area 1. Looking over at area 2, we're going from 0 to 1. And we start with our f of x this time. So we'll have the 15x minus the 2x squared minus the x to the third, and subtract the g of x, which is 0. Okay, so we have area 1 and area 2 written. Now, as I said, I'm going to say it again, I'm writing everything. So at this point, I'm saying 0 minus everything in that parenthesis, and so in area A, when we subtract that, it's going to distribute the negative. So we'll have a negative 15x minus, plus a 2x squared plus an x to the third. Okay, so that takes care of area 1. And taking care of area 2, we're taking the 15x minus 2x minus x to the third and subtracting 0. So it just stays 15x minus 2x squared minus x to the third. Okay, so now we're going to do our integration. I'm going to go ahead and change colors because we're kind of changing gears. So we're going to be integrating this. So we'll have a negative 15 over 2x squared. Because remember, we're adding 1 to the exponent and then we're dividing by the exponent. So that's where that came from. All right, so the plus 2x squared becomes plus 2 over 3 x to the third. And then the plus x to the third becomes plus x to the fourth over 4. And we will be looking at that from negative 5 to 0. All right, so I'm trying to use colors to show where things are coming from. So we're going to be adding this integration. All right, so the 15 over x will become 15 over 2x minus the 2x squared will become 2 over 3x to the third, and the minus x to the third will become minus x to the fourth over 4. And we'll be looking at that from 0 to 1. Okay, so from here, we are doing our plug and chug. So I'm going to do that in green. So we're looking here, and we're going to first be plugging in the 0 for x, and then we'll be plugging in the -5. When you plug in 0 for x, it will all become 0 because anything times 0 is 0. Then we're going to subtract where we're plugging in the -5 everywhere there's an x. So we'll have the -15 over 2 times -5 to the second plus the 2 over 3 times -5 to the third plus the -5 to the fourth over 4. Okay, so that, and I'll just write above it, that's our area 1. Right, now I'm going to stick with green, and we're going to work this one. So first, we'll plug in 1 everywhere there is an x. So we'll have 15 over 2 times 1 minus 2 over 3 times 1 to the third minus 1 to the fourth over 4. And I'm going to go ahead and put a bracket here to emphasize that that's the f of x part. And now we'll subtract g of x, which is 0. So that is our area 2. All right, hang in there with me. We are almost done. So when we, and I would strongly say, just slowly and carefully plug that into your calculator. Don't let it give you decimal numbers, because decimals can be rounded. So we want to leave this as a fraction. And what we come up with is 0 minus a negative 1,375 over 12. Or you could have done the whole thing, 0 minus, and then parentheses and so forth. but I went ahead and just left the 0 there because I wanted to be able to see it. All right, so now I'm going to add this part. All right, so again, I'm putting that into the calculator. I'm using my fractions, and what I come up with is 79 over 12 minus 0. So that will simplify when we have the 0 minus that fraction. It becomes a positive. So we'll have the 1,375 over 12, which is the area 1. And we're going to add the 79 over 12 minus 0, which is area 2, is just 79 over 12. And like I said, leave it as a fraction. So we're going to add those together and reduce, and we get our final answer of 727 over 6 is our total area. Lots of opportunities for mistakes here. Lots of opportunities, but I know you guys can do it. I am a big believer in the color coding, and I hope that you find that